Well, welcome. Some 20 years ago, when Adrian Bejan was awarded the J.A. Jones Distinguished Professorship, I was delighted to be the one to describe his substantial contributions. I'm equally happy now to introduce Adrian to this group with a list of accomplishments that is actually spectacular. He has received numerous honors, including the Benjamin Franklin Medal, big deal in engineering, and 18 honorary doctorates, and produced 10 recent books and hundreds of academic articles. Adrian Bejan is the discoverer of what's called the Constructal law, a physical theory which nevertheless identifies the similarities in structure and generating process between widely different phenomena. Constructal theory is a formal system that traces the development of complex systems, from river basins to the structure of large organizations, to patterns of information and energy flow. I was going to give you a non-mathematical form what it is, but I'll let Adrian do that. Constructal theory implies that in any complex system, there will be the development of a hierarchy. Not very democratic. And this hierarchy is both inevitable and beneficial. Some will get more than others, and this is both good and inevitable, he argues, the theory argues. A conclusion that will not please believers in social justice and equality of outcomes. Perhaps they will be mollified by the idea that the position in the hierarchy should depend on merit. Not everybody agrees. On the other hand, perhaps a meritocracy is less desirable than an hereditary aristocracy. Who suggested that? Dr. Samuel Johnson, 18th century wise man. And this is what he said. In the words of his faithful amanuensis, James Boswell, I'm sure you've all read Johnson, quote, I mentioned, this is Boswell, a certain author who disgusted me by his forwardness and by showing no deference to noblemen into whose company he was admitted. Johnson responded, suppose a shoemaker should claim an equality with him, as he does with the Lord. How would he stare? Quote, why, sir, do you stare, says the shoemaker. I do great service to society. 'Tis true I am paid for doing it, but so are you, sir. So are you, and I'm sorry to say better paid than I am for doing something not so necessary. For mankind could do better without your books than without my shoes. Then goes on Johnson, thus, sir, there would be a perpetual struggle for precedence, where there is no fixed, invariable rules for the distinction of rank, which creates no jealousy, as is allowed to be accidental. So, no meritocracy for Dr. Johnson. I wonder, does the Constructal law speak to this issue? Probably not. I talked briefly to Adrian. In any event, please join me in welcoming Professor Bejan's presentation on the topic, Nature, Humans, and Purpose. Thank you.
Thank you, Professor Staton. As usual, your comments are much better than mine. But you did make a mistake. You introduced me for my distinguished professorship 30 years ago.
Was it that long?
Exactly 30 years ago.
I'm sorry, your youthful appearance confused me.
No. It's one more example of the physics yeah, that time flies faster as you get older. Now I'll speak for only 25 or 30 minutes. I have only one disclaimer. It is that I will present things that I published after peer review.
Would you speak in the
physics
microphone,
journals and biology journals.
You want to speak into the mic, Adrian?
You hear me, don't you?
Yeah. Now we can. The microphone.
Okay, excellent. So what I'm presenting is already published, based on peer review. In other words, I'm not trying things, I'm not telling you tales. And the first idea is that when people talk about nature and humans, especially when scientists get into this discussion. There's a time arrow in the title. First is the general, nature, and then comes the particular. That's the usual way. I don't know, maybe I was born differently. My way is to go against methods. So I will talk about us, and hopefully you'll see nature by thinking about us. And that's basically the presentation today. And I'll begin with the questions. Have you, again, speaking of you, have you noticed that that the days are getting shorter as you get older? If you haven't noticed, you're still a baby, okay? Have you noticed that you tend to be attracted to things that look beautiful and look clear as opposed to confusing? If you haven't noticed, look inside your pocket. In fact, you are so attached to those things, you carry them with you, and you make really, really sure nobody steals them from you. The questions of this type are very numerous. I'll tell you one more. Have you noticed that when you make a fire, you shape it so it looks like the pyramids of Egypt seen in profile? These are things you do unwittingly. But there is a reason for these good habits. And so in my presentation, I would like to persuade you that if you pay attention to what you think, but especially to what you do, especially those things that you do without thinking, then you see the common thread. And along that path, you'll develop a pretty good understanding, a personal one, of what evolution is. And this understanding is a big deal, because evolution is one of the very few, not just enigmas, but very few divisive topics in human discourse today. So I'll begin with the easiest of these questions to you. It's about beauty. The things that we tend to prefer are of a particular shape. You have examples in this montage. You recognize them. In fact, you walk into any museum, you'll see hanging on the wall almost always images with a particular shape. I do not have time for the computer screen, the cinema screen, and the credit cards. This is not a new observation. During the Renaissance, a philosopher in what today is Italy observed this human preference and called it the divine proportion, a ratio of length horizontally divided by height that happens to be an irrational number, this 1.618 ... It is an important question to ask. In other words, to predict that yes, people should prefer this shape, and that way we have from science an answer, a scientific answer, a physics-based answer to what early on, when science was not available, was attributed to the divine. You see, this is how you discover that religion and science are actually very, very close. The only difference is that religion came first, and science came later as an add-on. And just like in sports, a player who has only one move is not as good as the player who has the two moves. Today, with these two human constructs, religion older, science more recent, we're much, much better. By the way, most of the flags of nations are shaped this way. There are very few exceptions. Nepal, maybe another one. All right, why is this preference happening? And why is the answer to the first why important? It is happening because before traveling from the eyes to the brain, the image is scanned. In our case, and also in the case of my cat and my dog, scanning is done with two eyes. The two eyes are aligned on the horizontal. By the way, did you ask yourself why the two eyes are aligned on the horizontal? This is the big change that gave birth to the Cambrian explosion, is because the world is flat. The world is flat, and so to perceive the world the fastest, the two scanners had to be aligned this way. All right, so that's scanning. Now, the scanning is done by the two eyes in abrupt, violent motions called saccade. And, the movement of the eyes is in all directions, except that because there are two eyes, where the left eye leaves off, the right eye takes over. And so during one time step of scanning, the length horizontally is bigger during that fixed time, and that means that the effective scanning speed horizontally is greater than vertically. That leads a physicist to the problem sketched at the bottom. Imagine you have a rectangular image. The area is fixed, but the shape is free to vary. Then what is the shape that empowers this particular object to be scanned the fastest? The answer is label axis. The image in the middle with a shape of 3 divided by 2, roughly, is providing easiest access from the page to the brain. Why is this important? It's very important because the animal that grasps reality faster is a more powerful animal. The animal gets out of danger faster, finds food faster, a mate faster, a dry shelter faster, and all sorts of other things faster. So access is really the meat and potatoes of life. This scanning discovery takes me to answering the second question. Why do days appear to be short as we get older? Well, the short answer is that mind time, meaning time in your mind, is not clock time. Well, so what is mind time? Mind time is a sequence of changes in the perceived image. Changes. The brain has finite volume. There's only this much, whatever, architecture in our construction, and that is highly precious. And it's only for what is new, for the changes in what's happening in front of us. Now, changes are interspaced or separated by time intervals. I call them time lapse. The time interval from physics is the ratio of two things: the distance traveled by the signal from eye to brain divided by the speed of that flow. That's the bingo, okay? The distance increases as the body grows. All the length scales in the animal design are increasing with time, all the way to adulthood. And at the same time, the speed of that flow decreases for many reasons. There is a path degradation, there is a rupture, there's also all sorts of things you read about in medical news. But more subtle is the fact that as the body size increases, the movement, all movements that are driven by muscular action acquire a lower and lower frequency. I'm getting to the saccades this way. The saccades of the older person are not as frequent, not as alive as those of the infant. You see this if you compare in your mind the stride frequency of the legs of the mouse with the stride of the elephant. By the way, the elephant is much faster than the mouse, but the frequency of the legs of the two animals is incomparable. That is what size has to do with the decrease in the speed of things. So the ratio of those two things is the time lapse. That increases with age. It means that now clock time. The clock was not invented by some person in the Middle Ages. It was, in fact, the fixed time. Yes, there's a physical time between sunrise and sunset. So at the end of the day, meaning at sunset, the older person feels that the sunset arrived too soon, because the old mind has received a smaller and smaller time clicks. So mind time is not the same as clock time. Now, in science and physics, this is an important because it reminds people that the concept of time is in fact personal. Time for me is not the same as time for you, and it's certainly not the clock time. And this sort of duality invites the physicists to recognize the obvious. In fact, I did not say it first. I think it was Einstein, that science is interesting because it is about us. So the observer and the user belong in the book of physics. All right, let's see what happens next. Now, the body grows. The body grows this way. These are measurements. It grows slow, fast, and slow. This is an S curve. You know, if you had children, that boy or girl in the teens goes through a growth spurt. So these are the facts. Now, the body is not a lump of, say, amorphous feta cheese. The body is actually a tissue on top of tissue on top of tissue of flow architectures, all doing what I sketched at the top. Every such entity in the body is facilitating a flow between one point and everything else. That everything else is a surface, like in the retina, or a volume, like the muscle that's in fact permeated by and fed by arterial blood. You can call these things tree-shaped flows or arborescent. However, when, or you can call them even pizzas if you want, but when you put them on top of each other in huge numbers, and when you see them from a distance, you lose sight of the structure, you lose sight of the function. But some of us recognize the fact that when you put trees on top of trees, you end up with loops. And so that thing looks like a net. It's called network. And why? Because with a net you catch fish, you see. The mother of the network is actually the thing with which you cannot catch fish, which is the tree. But when you have many of them put together, you have the animal. So S curve is how things that flow between point and an infinite number of points are actually growing. Not the flow, but the architecture is what grows. I have many examples of this phenomenon, the S curve. By the way, the S curve is predictable from physics. I don't have time for that. Here I show you examples of the biggest such flow architectures with their S curves. The most famous is at the very bottom. This is the world population. By the way, the world population is not a bunch of beans, filling a sack. The world population is a flow system, a movement similar to the rainwater on the plain, a movement that scans, flows on the surface of the earth. And according to the United Nations, this movement, yes, it increases monotonically, but it is predicted to reach its peak or its plateau, not peak, plateau, in the year 2050. This is the physics, it's important to know, and that empowers you to smile at those who talk about population explosion or exponential growth of population, or the end of this or the end of that. Now, why is the population tending toward a plateau? Well, it is tending because of the other two curves. The population is in fact driven, it is set in motion, it is consuming power that comes from a technology, which is the technology of power from fire. The upper curve is the power production in the US. And the second curve is the total miles driven annually in the US. Now, here you see movement physically. These are measures that have their own S-curves, and in their own way announce to the viewer the good news, which is that the Earth, with the people living on it, is not getting out of hand. All right. Now comes the subtle aspect of these S-curve developments. I said what grows in time as an S-curve is the architecture, not the flow itself. The flow itself could be spreading, as in the case of arterial blood into the muscle, or the water in the river delta, or the flow could be the other way, collecting from, like in the river basin, from the area to the point. In this case, we have an example of mining, oil extraction underground in Saudi Arabia. 100 years ago, the architecture was the single well. It was a needle. Over time, through improved drilling technology, the architecture of the well, like the architectures of all mines in the world, has become arborescent. Why? Because this design, which is evolving over time, is providing greater access from the underground volume to the point at ground level. And the important aspect of what I'm showing you is the time arrow of these changes in flow architecture. There is a direction. And that is, in fact, the message or the essence of the Constructal law, a statement I wrote in 1996. Sorry, I wrote it earlier, but I published it twice in 1996. For a flow system to persist in time. To persist in time is to stick around, and that is the physics definition of to live. How do I know what I'm telling you? I know because in thermodynamics from the mid-1800s, the opposite, which is nothing moves, is the physics definition of a dead system. So the opposite of a dead system is in the first line of this statement. So to live, it must evolve with freedom such that it provides greater access. This is a statement of physics. You can fit in it any narrative that makes you more comfortable, from biology to geophysics or social organization. I illustrated with three frames from a movie of the evolution of a river basin on the floor of a laboratory under the rain. The architecture is always a tree, but the tree from one frame to the next is different. In what way? It is different because it's getting better at vehicling the water from the plain to the river mouth. Now, evolution, according to this law of physics, is not a drawing. It is not a photograph. It is a movie. And the movie has no end. The movie tape has direction. The movie tape rolls in one particular direction. The direction of that is actually the arrow of time of what we perceive. The arrow of time in physics, the one that concerns humans, is not toward the entropy death of the universe. That's a nice story. But right here on Earth, or in the meantime back in the United States, what concerns us is what's going on outside the window. And the arrow of time there is the one sketched here. The example is, of course, water in the river basin. Here is a river basin of people that is on the ski slopes in Utah. I get goosebumps when I look at this. This was sent to me by a Duke undergraduate who took my Constructal law course about 6 years ago. And he went skiing in Utah and then went to the clubhouse. He wrote to me, and while drinking a beer, he looked at the slope and thought of me, you see. So, yeah. And that is the greatest compliment I ever received from anybody who is associated with Duke, okay? All right, so rivers of people. By the way, scanning the slopes, okay? I'll come back to that a little bit later. What's left in my talk is organized in a sequence of 3 keywords, which keywords that describe the direction of evolution everywhere. Animate, inanimate, you saw river, water, rivers of people. I have lots of these examples if you're curious. Diversity. Now these things that move, in this case people, the people who are flying all over the globe, are these. Airplanes do not happen by themselves. A little bit later you'll see I call them specimens of the human machine and machine species. At every point in time, say year 2000, these new animals are appearing on the landscape in many sizes and in configurations that are both similar but not exactly the same. Just look on the vertical. So diversity is in play. And so is hierarchy, because the big ones tend to be a lot fewer than the smaller ones. They all have 2 wings, and they have a fuselage and a few other common features, but some have 2 motors, others have 4. There are some other variations, so diversity comes from the fact that they are not exactly the same. Who made them? Boeing or the French were the former USSR. Interesting, but why is that? Well, for that we have physics. And here is the answer in terms of these other animals or trucks or vehicles. Animals are vehicles, okay? They have body to be moved. They have a motor that provides the power, that drives the movement. And of course, the animal consumes its own fuel. It has exhaust. Use your imagination. And so thermodynamically, animals are the same as everything else that moves on Earth, including the rivers and the winds. Now, here's diversity. The upper, I made these drawings, okay? The upper row shows you the obvious. These animals are not the same. In fact, that's why they have different names. Now, of course, the bottom row is the joke. I made these animals to be the same size in order to hit you with diversity. You notice what used to be small in your mind is a drawing that has relatively smaller legs, meaning legs that occupy a smaller fraction of the body weight. Those legs, by the way, are also skinny, compared, meaning slender, compared with the opposite end of the row, where the legs are a bigger fraction of the body, and the legs are more robust, more stubby. So that's diversity, and this variation in body size fraction is actually predictable from physics. It has to do with the physics of locomotion, what
the physics of getting the body off the ground. The same is true about say, the wings of a flyer, from the hummingbird to the albatross, if you want, or in swimmers, from the guppy to the whale is the same sort of thing. I'm talking about there, the lifting organ is the tail of the swimmer. And all that is predictable, and this sort of variation is really the physics of diversity. It is why we don't look the same. If you want me to elaborate, I'll tell you during questions and answers. The other key word is power. Nothing moves unless it is driven. Okay, and the driving for the Homo sapiens happened dramatically toward more through the control of fire. That was 1.5 million years ago. Fire, and so from such a long time ago, nobody remembers why all of us know how to shape a fire. We shape it this way. This is a pile of charcoal being the best that it can be. Now, actually, I made this fire in order to convince you that I'm not lying to you. Now, the physics problem is sketched in the lower left. You can show almost on the back of an envelope that if the volume of fuel is fixed and the shape of the pile, the pyre, that's the name for the construct, is free to vary, then the hottest body is the one that has a horizontal dimension that's approximately the same as the vertical dimension. In other words, the pyre has to look like the pyramid, because that is the smartest way of empowering the user. Why is that smart? Well, from prehistory, it was very difficult to make a fire. Never mind, how to light it by knocking 2 stones. You had to find dry wood, especially when it was cold and rainy outside at night. If you haven't had that experience, take my word. I grew up that way. It's not easy. So it's important to know how to make a fire that's the hottest per unit. What record do we have, really, that prehistoric, people were shaping the fire this way? I asked myself this question, and I said, well, maybe language answers that particular question. The Greek word for pyre is pira, okay, from which the Greek word for the pyramid. You see. Now, according to my understanding of history, the Greeks were making fire much, much earlier than they ventured down south to observe the pyramids. So, pyre means fire and means the shape that became famous not only as a description of the pyramids, but also famous in geometry. Much, much older than the pyramids. Okay, at the bottom we have what happened next. So fire was the first step in power technology. Today, the world is kept in motion by all sorts of fires in the power plants, in the engines of automobiles and airplanes and everything else. Every week, scientists are actually shaping the fire inside the working cylinder, so that that particular motor is empowering you, the user, more and more per unit of obviously money you paid, but per unit of fuel burned, or per unit of mass moved from A to B on the world map. So, and that that invites the viewer to imagine this history of movement because of more and more power. I made this montage by using words that are not really used in physics. There are two directions or two axes. On the horizontal, we have terms of social organization, from the band to state and the global designs today. On the vertical, we have the physics of what moves these things, meaning fuel used with purpose. Both axes have a direction in time. Time increases, in this case on the diagonal, from one of my drawings to the next. You notice how population grew on the diagonal to the point that I cannot draw it anymore. Okay? So that's a little bit like preaching to the choir. I made an alternate drawing. This from memory, equipped with knowledge of the physics of fire and fire use. Imagine that how it was when people with fire had to produce hot water for cooking or for heating the hut. Well, in the beginning, because in the beginning the population was sparse, it was disconnected. These were one hut here, another one on the other side of the forest. There was one fire and one pot with heated water for each settlement, and that is the beginning of the movie. Okay. Now, to make fire in one pot is to waste a lot of fuel, because there is heat leaking from the pot. That's one bad design feature, wasteful. The other one is that most of the so-called heating goes up in smoke. It misses the pot. And we already established the fact that finding dry wood is a real hassle. So it makes sense, or it made sense for people over time to find better ways of heating water. That's in the next step. One big pot for a cluster of users, meaning one big pot. The users simply took water from the pot. The bigger the pot, the more efficient the heater. That's called economies of scale. The whale is essentially highly insulated by its, because it's big. The whale, the hippo, all these big animals are they don't leak heat. The animal that leaks heat is the tiny one, like the single pot. And so in the direction up the diagonal, better ideas occurred. By the way, time in this case is once again the arrow to the right, because with advancement, people used more hot water, or think of it the other way, because of the hot water use, they became more advanced. All right? And so in this direction of evolution of the configuration, social organization discovered the whole dictionary of terms, such as economies of scale, organization, networks, trees, vasculature, division of labor, trade money, social fabric, all the way to the top, which is hierarchy. The most efficient, you can show this with calculations of how the hot water making is becoming more efficient. The most efficient is the one where the population is covered by three groups of users. The many are those who use hot water. There's an intermediate group that distribute hot water. And then the smallest number concerns those who actually heat the water. The water heating member of the group is in the center. That person is surrounded by, in this case, 1, 2, 3 distributors, and then you see the entire bunch of grapes constitute the population that has access to hot water. So you see, with eyes closed, but with knowledge of, in this case, the physics of fire making and fire use, the history of social organization emerges not only in plain view, but in a way that's irrefutable. And so I arrive at this keyword, which is hierarchy. And hierarchy, you saw it in this example, but it is in fact everywhere. And I come back to the two eyes that scan the page. These are examples of how people scan the surface of the earth with their feet. In the upper left, the Atlanta airport. Every individual has the urge to have access from one point to the whole area. Arriving individual or departing individual. Now, out of that desire that is shared by this very large numbers of visitors to the airport, emerges the design of the airport, the configuration of the airport. If you pay attention to the prizes or honors that industry gives annually to airports of the world, you notice that from year to year, the airports of the world are evolving. They're getting better. They're providing greater access. They're evolving to look more and more like the Atlanta airport. Even though the Atlanta airport was built in 1956 without asking me. Then I would not have known the answer. Now, the other examples, freight, the movement of anything on Earth is actually a scanning operation. The stuff moves from one point to the whole area, and it does so, just like in the Atlanta airport, in two ways, fast and slow. Fast is long, the slow is short, the short is transversal to the fast. That for freight. Much more prevalent, but less known is the so-called food chain. Animals coexist on an area in this combination of two. The long and fast are the predators, the short and slow are the other population, the prey. And together, on the same area, they live because of a superposition of such, they call them couples of systems. The prey are also, of course, preying on smaller animals all the way to insects, and all of them together, of course, depend on the vegetation on the area. And but the word that connects all these drawings is hierarchy, because on every area, the large, fast, and long are few, and the other ones, the small, slow, and many are, sorry, you get the idea. All together, they're moving, and they're moving the same stuff. Now, the biggest area that we can think of in this unifying manner is the whole globe. This is how humanity is scanning the globe via air travel. This is not a painting. This is these are measurements from satellites, measurements of the condensation trails left behind all flying aircraft. They show that okay, everybody's flying, more or less, meaning jet setters are a thing of the past. Now everybody's flying. Those are in the blue. And just like the red blood cells in the animal design, sooner or later every cell has to flow through the heart. And now you see where the heart is, and also where it will stay. The heart is in the North Atlantic, which is, by the way, where the air travel was born and perfected historically. And this particular architecture or vasculature is growing, is becoming more robust, but the animal is not changing. Now, we know from river basins and the skiers and all these other examples that the movement movement naturally evolves to be hierarchical to provide greater access. The movement is driven by fuel. That means, of course, from physics, that fuel evolves on the globe to be consumed hierarchically. There's no other way, because you see, nothing moves unless it is driven, and the driving comes from fire, which consumes fuel. So in this image, the message is that there is hierarchy in movement, therefore in the consumption of fuel. And now the coup de grace, the plot I made on the right, these are facts that come from economics. On the abscissa, the fuel use in all the countries of the world annually. So on the abscissa, fuel consumption. On the ordinate, what in economics is recognized as wealth or gross domestic product. There's a surprising, not to me surprising, but to most people surprising alignment of all these living groups. An alignment that indicates that, that wealth and the physics of movement are in fact two sides of the same coin. And that coin is what? Let me review. Movement on the globe is hierarchical because of its very nature, because of the tendency toward access. The consumption of fuel is therefore hierarchical. And that, of course, is translated into the distribution of wealth is hierarchical for the same natural reason. To restate this conclusion, I would say that the occurrence of wealth hierarchy is as natural as the occurrence of a movement that's organized hierarchically to be more efficient and more economic and all these other things. All right, so these flow architectures, the movement of the living is in fact evolving. It's evolving because of just like the floods. The floods are invading because they are full of movement compared with the marsh that surrounds them. This not intentionally coincides with how the heart of human movement on the globe developed two chambers across the North Atlantic 500 years ago. Now, the movement intensifies relentlessly through the evolution of, in this case, transportation technology. You see here images that speak of a movie for boating and vehicles. And almost finally, a piece of art that I composed that speaks of who we are. We, even long before the adoption of fire, stopped being the Homo sapiens, the naked body that you see sketched in the anatomy book. That drawing from the anatomy book is good for the morgue. The morgue. The human body is in fact not alone. It is accompanied by add-ons, by contrivances. The tissue of the shirt is one of them. The shoe, all of these things. The rope and the pulley. The name for all those things, all those add-ons from Greek is mihani. Mihani means contrivance. It means artifact. It doesn't mean machine. Machine is the latest version of that type. So that's why I call us the human and machine species. And it is this species, the human machine, that's evolving every minute that I speak. It is evolving because of the machine part. The other one is evolving, perhaps. I'm not a biologist, but the time scale of the evolution of the naked Homo is a totally different thing physically than the time scale of what's happening to my iPhone, you see. And so I conclude with this slide, which answers your, I'm sure, most burning question, which is how can I read more about this this way of looking so simply and powerfully as nature through my own soul. Is this book, which is actually a very good book, and then on the left-hand side a collection of keywords that sneaked in our discourse, even though traditionally they do not belong in physics. You see them here, and I'm surprised I did not put wealth on the list, but you get the idea. From beauty to to diversity, I think you begin to see that even without studying physics or biology, you know plenty about evolution. Thank you.